Hello, I'm Kuncheng. This is the homework 5 problem 2 presentation for the course Probability and Stochastic Process. Okay, let's see the problem. So, for the problem 2, it's given fxy equal to 1 over 8 times 2 y squared times x, and we have the limit is y have to greater than 1, and we have x greater than 1 over y and less than 1. And for first question, we have to draw the non-zero definition region of the fxy. For this one, we have to use this limitation. So we have x greater than 1 over y. So first we have to get the curve of the x equal to 1 over y, like here. So for this curve is x equal 1 over y, and another one is x less than y. So we have to get another line is x equal to y. So we can, according to the y have to greater than 1. So according to this function, we know the region of the fxy have to at this side, because this point of the two function is 1 1, because we just use this function, we can get the intersect is the point is 1 1, and because y have to greater than 1, so for this side is not on in the region. So and x have to less than 1. So for this side, the region in this side, and for this curve, the region in this side. So we can, in summary, the shade is here. This is the region. So okay, let's do the second question. The second question is to find a if fx is a valid joint density function. We know if the fx is a valid joint density function, we have to satisfy the fx equal to 1. So we have the function is like the double integral for the function fx is a times dx dy equal to 1. So now we have to know the range, the region. So according to the first question, we can get here. For the first is the axis, the range of the axis. So we have the x equal y, and we have the right side. Right side is x equal 1, and the left side is x equal to 1 over y. So we have the function is the range is y 1 over y to y, and the second integral is the range of the y axis. So you see the region. So from the from the 1 to infinite. So like this, and we copy the function and we just calculate the integral. Let's do this step by step. And here, because this is the integral respect to x, so we can move 1 over a times y squared to here, and we just get integral of 1 over x, and we can equal to get times a, and like we just write line y minus line 1 over y. We just plug in the range, we get this, and we just together one more division. Oh no, the integral, and we can move the a 1 over a to the outside of integral, and we got, this one we can get line y, we just get line y square and divide y square dx. And also we can move this square to the outside, we get 2 over a. We got here line y divide y dx. Oh no, not dx, dy, sorry. And we can let line y equal to the z and plug in the function, and we got 2 over a, and write the integral and plug in the line y equal to z, and the y square equal to the z, exponential 2z square, and the exponential z square. And we can move the exponential z square inside, like here we got z times exponential z minus z dz. Now we use the function according to the integral function is, you see the integral u dv equal to uv minus integral v du, and we let u equal to z, v equal to e minus z, and for the integral we can get, here is z is times e minus z square from the 0 to infinite minus integral z minus z dz equal to 1. And according to the expanded easy calculation, and we can get a equal to 1. That's for the second question. And for the third one, we have to find and draw the marginal density function. Means we have to get fx and fy. According to the function, we can easily to get fx equal or fy equal to the integral fxy dx, and we know the range is 1 over y to y, and we know a not to equal to 1, a equal to 2, and for the here we have to plug in 2 times y square x dx, do the integral, and we get line y over y square, and in the range, and we can have the graph like this, fy. This one is y. Also, fx, for the fx, a little bit complicated, because for the x, we have the two situation. The fx also equal to from the negative infinite to infinite fxy dy. That's the function. And because we have the two situation is when y, because y have to greater than 1, so x have the two situation is when x greater than 0, less than 1. Another is x greater than 1, less than infinite. So for this one, we have x to have integral the here, and write the function dy and calculate, get 1 over 2. And another situation is we just change the range is infinite to x, and write the function dy and equal to 1 over 2x squared, and we can get graph that's the fx, because this point is 1, before the 1 equal to 1 over 2 and greater than 1, we have the curve. And for the last question is verify the fx and fy are valid density function. Also, that's easy because we just do the range. We have the function of the fy dy and equal to 1. We just verify this one. It's done. So for this one, we already get from the second question here. We also prove that because a equal to 2, we get here a equal to 2, so this one is 1. And because the whole thing is the valid density function, so also equal to 1. So this portion equal to 1 also. So we have to prove that. So this one is 1. So fy is valid density function. So let's do the fx. Fx, we have two portions. Fx, if you want to verify that, we have to know the integral from 1 to 0, 1 over dx from, you see 1 to 0, the fx equal to 1 over 2, and plus from the 1 to infinite, we have the here dx. This one easy to see that it equal to 1 over 2, and we do the integral here, like we just do this. We got x minus 2 squared dx. We just do the integral here, equal to 1 over 2 plus 1 over 2 times integral. Integral. We just to get minus x minus 1. Because this one, the division of this function equal to x minus 2. You can easy to get that. And from the to infinite, now we can easy to get the outcome equal to 1. So fx is valid density function. So that's it. That's the whole the problem 2.